I would like to continue with the molecular orbital theory diagrams. So I have given some of the diagrams of some homonuclear molecules. So in case of homonuclear molecules, it is quite the same for all, just electrons are different, and as an exception is there is that about sp mixing. I have given the explanation that with size, as along a period the size of atom decreases from left to right. So what happens, the distance between the s and p orbitals, the consecutive s and p orbitals gradually increases. Distance increases. If distance increases, then this mixing, sp mixing ability decreases for an atom. So if this sp mixing does not happen, so what happens, the 2p orbital combine to give 3 orbitals, 6 orbitals, 3 and p bonding, 3 bonding, but 3 orbitals, namely mainly what, pi to px, pi to pz, and sigma to pz. And when sp mixing occurs, then what happens, the sigma pi to px and sigma to pz, this is pi to px, pi to py, and this sigma to x, this is the, okay, this is from the down, this is power 2s power. ইহন দুটাৰ মিক্সিং হয়, তাৰ মাজত ইহন দুটা, এর কারণে কি হয়, ই অলপ স্লাইটলি অরিজিনালি ইয়াত থাকে, তলে আহে, সিগমা টু বিজেট তো অরিজিনালি ইয়াত থাকে, আৰু কি পড়ে যায় when sp mixing occurs. যেতিয়া sp mixing নহয় for small size molecules, যেতিয়া মানে লিথিয়ামৰ পৰা নাইট্ৰজেনলৈকে এইখিনিলৈকে sp mixing হয়, কিন্তু from oxygen, fluorine, neon sp mixing নহয়, তেতিয়া কি হয়, a sigma to b to originally sigma to s ৰ লগত mixing হ'ব নোৱাৰে because of large distance between 2s and 2p. So what happens, sigma to pz will be in the downside, আকৌ নিজৰ জেগালৈ আহি যায়, pi to px, pi to py will be there, and sigma to s তললৈ যোৱাটোকে আকৌ নিজৰ জেগালৈ আহি যায় আৰু ওপৰলৈ গ'ল, এইটো sigma to s. So this happens when sp mixing will not occur. এইটো কোলেকে হয় লিথিয়াম, from lithium to nitrogen, and এইটো কেতিয়া হয়, when sp mixing not occur, is fluorine, neon, oxygen, fluorine, neon. So sp mixing হলে sigma to be to ওপৰত থাকিব, pi to px, pi to py তলত থাকিব, আৰু sigma sp mixing নহলে for oxygen, fluorine, neon, because of small size s and p orbitals আমাৰ distance to বাঢ়ি যাব, sp mixing নহয়, তাৰপৰা কি হ'ব, sigma to be to তললৈ গুচি আহিব, এনেকৈ pi to px, pi to py ওপৰত থাকিব, sigma to s তলত থাকিব. এইটোৱে হৈ গ'ল মেইন বেসিক ডিফাৰেন্স ফৰ homonuclear molecules, molecular orbital diagrams. Now we have to understand some of the important and basic diagrams of heteronuclear molecules. So for heteronuclear molecules, what we have to first understand is that difference in electronegativity, number one, first point. Second point, relative electronegativity, with respect to hydrogen atom. এতিয়া মই কি কৰোঁ যে কিহত বেছ কৰি পেলাই আমি মলিকুলাৰ অৰবিটেল থিয়ৰী ডায়াগ্ৰামবোৰ পঢ়োঁ, অৰিজিনেলি উলিয়াইছিলে বা এতিয়া আমি পঢ়িব লাগিব। ইলেক্ট্ৰনেগেটিভিটিৰ ওপৰত বেছ কৰি দুইটা এটমৰ যিকেইটাই আল্টিমেটলি মলিকুলটো ফৰ্ম কৰিছে। ছেকেণ্ড কাৰ্বত ডিপেণ্ড কৰিব লাগিব হাইড্ৰজেনৰ ৰেচপেক্টত তাহাঁতৰ ইলেক্ট্ৰনেগেটিভিটিটো কিমান ডিফাৰেঞ্চ আছে, কাৰ্বন বেছি নে কম নে বহুত কম, চ' এইটোৰ ওপৰত ডিপেণ্ড কৰি গৈছে। নেক্সট কথাটো মই ৰাখিব লাগিব সদায় higher is the electronegativity, lower is the energy, more will be the stability. So in case if we know that hydrogen is what in this area increasing, if we arrange it increasing energy, so since as we go through a period, the electronegativity value increases. Why? Because Z effective, the number of protons increases, nuclear size increases, Z effective increases, so whatever electronegativity also increases. So hydrogen is what this, then comes lithium, then beryllium, then boron, then carbon, then oxygen, then nitrogen, then fluorine. So as we move down move across a period from left to right, electronegativity increases because of increase in Z effective. So with electronegativity we have learned that lower is the energy, so energy will be lower, and when energy is lower, that means stability is more. So when we write or draw any molecular orbital diagrams, we always focus on first electronegativity of the atom. If it is between carbon and oxygen, so oxygen will always be placed lower because of its high electronegativity and more stability compared to carbon. So from this diagram we can clearly know that how electronegativity affects one's energy as well as stability. First concept. Second concept is that in some cases, again from this we can understand the distances. For lithium there is say 2s, 2p. For beryllium again 2s, 2p, 2s, 2p, again 2s, 2p, 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 2s, 2s, 2s. So this energy, these distances, as we move across a period from left to right, the distance between the respective cells S and P orbitals increases, as a result of which sp mixing does not happen towards the back end, right side of a period, because of its small size, increasing distance between S and P, so sp mixing does not occur. So because of this, again its energy decreases and it becomes stable. Okay. Next, in case of homonuclear molecules, for if one atom is if one atom has more size or less size, so in both the atom there will be sp mixing. If not, then there will no sp mixing in the whole molecule, because the two atoms are same. But in case of molecular orbital theory diagrams of heteronuclear molecules, the two atoms are different, so one may experience sp mixing because of its size, one may do not experience. So in this case we always have to remember that while drawing the molecular orbital diagram. In one atom we have to consider the sp mixing. If it has sp mixing, and if the other atom does not cause sp mixing because of its small size, then it will not consider its sp mixing case for its own. If an যদিও মানে কি হয় কাৰ্বনত এইটো বস্তু হয় বা অন্য এটমটো তাৰ লগত থকা এটমটোত হয়, গতিকে এইটো নেচেচাৰী কণ্ডিশ্যন নহয় যে এটা sp মিচিং হ'লে ইটোৰ হ'ব লাগিব। ইন কেছ অফ হেটাৰনিউক্লিয়াৰ মলিকিউল এটা নিজৰ আইডেণ্টিটিটো যেনেকুৱা তেনেকুৱা সিহঁতি ৰাখে। চ' এতিয়া ফাৰ্ষ্ট অফ অল আমি তেতিয়াহ'লে দুটা হ'লেও ড্ৰয়িং আমি চাওঁ, তেতিয়াহ'লে গম পাই যাম। So first, let's see the diagram for HF. So what happens in HF? So first of all, we draw the energy line. This is the energy line. Okay. Then for hydrogen fluoride, the electronegativity of fluorine is very much high, that the molecule the atomic orbitals that combine is not of the same orbital, same orbital and identical orbital. For example, if this is 1s for hydrogen, then this is the 1s for fluorine, this is 2s for fluorine, this is 2p for fluorine. So the 1s orbital's energy is very high as compared to fluorine's 1s and 2s, that it cannot combine to form linear molecular orbitals with these orbitals. So in case of HF, the 2s and 1s orbital of fluorine remains as non-bonding. Done. So one is 1 and fluorine is 1s2, 2s2, 2p5. Okay. So now these 4 orbitals will combine to give 4 atomic orbitals 2p of fluorine, 3 2p orbitals, 2px, 2py, 2pz, and 1s orbital of fluorine to give 4 molecular orbitals. So what will be the 4? First of all, there will no sp mixing here. There will no sp mixing here. So sigma to pz will be down. Pi to px, pi to py will be what? Up. Okay. And this is pi to px, pi to py star, and this is sigma to pz. This is pi to px, pi to py, pi star to px, pi star to py, sigma star to pz. So 1s orbital. So how many electrons are there? 1. 2p orbitals. How many? 5. 1, 2, 3, 4, 5. So first of all, what will happen? Sigma to pz will have 2 electrons out of these 2. 1 from this, 1 from this. Again 4 left. Then what will happen? This 2 will contain. Okay. So this is 4 left. And 1 from this, 1 from this. So 1, 2, 3, 4. 4 will be left. So 1, 2, 3, 4. Okay. So but we'll know that from 2p orbitals, when two 2p orbitals combine, then what happens? 6 atomic orbitals combine to give 6 molecular orbitals. Always remember, number of atomic orbitals will be equal to number of molecular orbitals formed. So here what happens? 1s orbital has high energy, so that it cannot combine with this 1s and 2s of fluorine, so it combines with 2p. That means how many orbitals combine in atomic phase, in atomic level of কেটা এনার্জি, কেটা orbital combine হল 1s হাইড্রোজেনৰ এটা orbital, 2p of fluorine তিনটা orbital, তিনটা atomic orbital form হৈছে। so যিমানটা atomic orbital combine হয় সিমানটা molecular orbital form হ'ব। তিনটা চাৰিটা atomic orbital combine হৈছে চাৰিটা molecular orbital form হ'ব। এটা দুটা তিনটা চাৰিটা পাঁচটা ছটা। so this asymmetric combination will not result in 6 in this proper way. This is the proper way when both 2p orbitals combine, this arrangement will happen. But in this case it will not happen, because number of atomic orbitals is 4, but number of molecular orbitals will be 6, which is not possible. So this is electron filling is right, but this arrangement is wrong. So what will be the change here? So always remember, for when two atomic orbitals combine, two molecular orbitals will form. So for this state, let's say 1s orbital of the hydrogen combined with the 2px, say 2px orbital of fluorine. So this 2px and 1s combination gives two molecular orbitals. Two atomic orbitals combine, two molecular orbitals will form. What will be the sigma? This for this is bonding, this is anti-bonding. So one will be bonding, one will be anti-bonding. Alternative. These two forms. Then what happens? 1, 2 electrons come to, so it is filled. First bonding will fill because of low energy. Then will go to upper energy. So again, how many are left? 4. So these 4 electrons in the py and pz orbitals have no corresponding atomic orbitals in hydrogen to get combined from molecular orbital. As a result, these two atomic orbitals remain as non-bonding. So these two will remain as non-bonding. So for this two will be filled. This will be what? NB. This will both be NB, that is non-bonding electron. So for HF molecule, these are homo and this is LUMO. So homo and LUMO will be this. So these are the frontier molecular orbitals FMO of HF. What are frontier molecular orbitals? So those molecular orbitals from which donation and acceptation of electrons can be done, and which tells us all about the molecule stability, either thermodynamic or kinetic stability, its reactivity, everything, every information from it can be achieved from those molecular orbitals, that orbitals are known as frontier molecular orbitals FMO. So in this way the molecular orbital diagram is given. So if HF has to donate electrons, it will donate from this non-bonding electron as is HOMO, highest occupied molecular orbital. Next, these non-bonding electrons are mainly from fluorine, because these 4 electrons are in the 2p orbitals of fluorine. So when HF acts as donor, So it donates from fluorine side, not from hydrogen side, because there is no non-bonding or highest molecular orbital present towards hydrogen. So again another thing, if the HOMO is in two or degenerate orbitals and if it is fully filled, যদিহে HOMO-টো দুটা degenerate orbitals or combination হয়, second point to যদি he fully filled হয় তেতিয়াহলে it will be a good sigma donor as well as pi donor. So যদিহে HOMO-টো দুটা degenerate orbitals মাজত থাকে আৰু দুইটা atomic orbital দুইটা orbital যদি fully filled হয় তেতিয়াহলে তাক কি বুলি কয়, the good sigma donor as well as pi donor. So HF is a good sigma as well as pi donor. So how many frontier electrons are there? If it is given, then always frontier orbitals are HOMO and LUMO, from where the donation and acceleration is done. LUMO does not contain any electrons, so electrons are there in HOMO. HOMO are two orbitals, so there are 4 electrons. So frontier molecular orbital electrons are total 4, and in case of frontier orbital lone pairs or in case of electron pairs it is 2. So in case of HF, frontier orbital electrons are 4 and frontier orbital lone pairs are 2. So now let's take a look at the diagram of carbon monoxide. And in case of say HF bond order, so in case of bond order, always remember number of bonding electrons NB and number of non-bonding electrons, number of anti-bonding AB divided by 2. So in case of bonding electrons, the down part has no significance in it, so let's leave it. For the excited part, 1s of hydrogen and 2p of fluorine, there are 1 2 3 4 5 6 bonding electrons, 0 non-bonding electrons. So 6 minus 0, 2 throw, bond order is what? 3. So bond order is not 3 because non-bonding, this is only bonding. So this is not 6. Sigma 2p is the 2 electron, so these are the only bonding. So anti-bonding on eta নাই, non-bonding on 2 আছে, এটা bond order তাহলে কোনো contribution নাই because তারে lone pair হিসাবে থাকে, তারে bond না থাকে. So 2 by 2 this will be 1. So bond order of BF is 1. আৰু ইয়াৰ paramagnetic behavior নাই, দি diamagnetic হয় আৰু তাৰ electronic transition কথা আমি ইয়াত ক'ব পাৰোঁ, এটো হৈ গ'ল NB ৰ পৰা pi লৈ যাব, NB ৰ পৰা pi star লৈ transition in case of BF. So homotulone. Now carbon monoxide, this is now the difference between carbon and oxygen is not very much different. So in case of carbon and oxygen, so we have to take in take the condition of sp mixing. In case of carbon, there is sp mixing because of its height, because of its what place in the periodic table. It is slightly smaller than pure sp mixing causing such as lithium, barium, but here sp mixing happens but not that ideal. So as a result of this 3 2p and 1 2s, this 3 2p and 1 2s, so for this 1 2p and 1 2s will combine to give 2 sp mixing hybrid orbitals. So one of the 2p is removed and the 2s is removed, then what happens? 1 and 2 hybrid orbitals are formed. Other hybrid orbitals, this is say spz1, spz2. So these are px and py. So this is slightly, spz2 is slightly anti-bonding, spz1 is slightly bonding. So how they are formed? They are formed by the mixing of s and p orbitals, s and 2s and 2pz orbital of carbon. Because in case of carbon, because of its larger size as compared to oxygen, there is sp mixing present, but in case of oxygen there is no sp mixing. Okay. So for the this 2s, this is 2p. So for oxygen it is 1s2, 2s2, 2p4, and for carbon it is 1s2, 2s2, 2p2. So one, two. This is, there is one. So this spz2 is slightly anti-bonding, this spz1 is slightly bonding. So this spz, this 2s is that stable that it cannot mix or so this 2p orbitals, this 2p orbital, one will combine to give what? How many orbital combine? 1, 2, 3, 4, 1, 2, 3. So how many molecular orbitals will be formed? 7. So this spz2, this spz1 and 2p will combine with what? To form sigma. Okay. Again this will again give sigma star. This will remain as non-bonding. So with some mostly slightly anti-bonding character, slightly anti-bonding character. So what will happen? Again these two will combine with these two. As a result, 2 will be formed again in the above, I guess slightly down. This is slightly above, this is slightly above, this is slightly down. These two will combine. So how many orbitals will be formed? This spz2, these electrons are filled here. Again, how many electrons? These 2s, these 2s2 will be NB. So 2s of oxygen cancel. Cancelling these two, for oxygen number of electrons will be 4 to be filled in this. For carbon up from 2s, number of electrons will be but 4. So 8 electrons have to be filled here in this pi and pi star, which is sigma star, out of which 2 are NB. So 6 electrons. So 1, 2, 3, 4, 5 and 6. So here what? This will be HOMO, frontier molecular orbital 1. this will be LOMO. So in case of HF, in the earlier case, the frontier electrons are 4 and pair is 2. In case of carbon monoxide, the frontier molecular orbital is slightly antibonding character, LOMO, and HOMO, non-bonding, and frontier electrons are 2, pair is 1. So as these frontier molecular orbital electrons are mainly mainly in the carbon side, more from the carbon side though. So in case of transition elements or in case of coordination compounds as ligand, carbon monoxide, or in organometallics we have seen that the electron gets donated from carbon side, not from this oxygen monopair. Why? Because the orbitals that are available for donation in case of carbon monoxide ligand or carbon monoxide molecule is more towards carbon or more from carbon. কার্বনৰ এই নন বন্ডিং ইলেক্ট্ৰনবোৰৰ ওপৰত বেছি তাৰ ডমিনেশ্যন আছে, তাৰ বেছি তাৰ কাৰ্বনৰ সাইডে আছে ডমিনেশ্যন, আৰু এগেইন দিস ইজ স্লাইটলি এন্টি বন্ডিং ক্যাৰেক্টাৰ. সো দিস নন বন্ডিং ইলেক্ট্ৰনস উইল স্লাইটলি decrease its bond order. So if you see here bond order, number of bonding electrons are 1 2 3 4 5 6 6. Number of anti-bonding electrons are 0 divided by 2. 6 minus 0 by 2 will 3. So carbon monoxide is 3 bonded, but the third bond is not very much strong. This bond usually breaks easily. Why? Because this non-bonding electron, as it is slightly anti-bonding character, it reduces or it decreases the strength of the triple bond or reduces the bond order from 3. So due to this reason, the carbon monoxide, the third bond is not very much strong. So it is a 2 electron donor molecule from and the donation takes place from the carbon monoxide side. The nitrogen monoxide drawing is also same. For nitrogen monoxide, the electronic configuration changes to 2p3. So in this way only spz2 spz1 will be formed. So in case this will have 2 electrons, these 2 electrons will fill in sigma pi 2 pi orbitals and nb, and the last electron will be filled in the pi star. So in case of nitrogen monoxide, the whole diagram is same, but due to this extra electron is in the antibonding electron and antibonding orbital, so its bond order decreased by half, because in case a molecule's electron is increased in the antibonding electron, its bond order decreases by half for each electron, and for bond order to be increased, its bonding electron will be increased. So as নাইট্ৰজেন মনোক্সাইডৰ কেছত কি হৈছে, পাই ষ্টাৰত এণ্টিবণ্ডিং ইলেক্ট্ৰন বাঢ়ি গৈছে এটাৰ কাৰণে। চ' কাৰ্বন মনোক্সাইডৰ তুলনাত তাৰ কি হ'ব, বণ্ড অৰ্ডাৰটো মাইনাছ হাফ কমি যাব। চ' ইয়াত দেখা দেখি ডাইৰেক্ট উলিয়াব পাৰি 2.5 ওলাব। আৰু যদিও মই যদি ইয়াত চাওঁ বণ্ড অৰ্ডাৰটো, ইয়াত যদি মই বণ্ড অৰ্ডাৰটো চাওঁ কাৰ কাৰণে, ফৰ নাইট্ৰজেন মনোক্সাইড, তেতিয়াহ'লে কি ওলাব, বণ্ড অৰ্ডাৰটো bonding electrons 1 2 3 4 5 6, antibonding electrons 1 divided by 2, 5 by 2 and 2.5. This is the bond order for nitrogen monoxide. So this is also same, but here donation from pi star, so it is a pi donor. But again from nitrogen side the donation take place, not from the oxygen side, because this molecular orbital is more nearer to the orbitals of nitrogen rather than oxygen, because oxygen is more electronegative, so its energy is slightly lower. So in this way, every information of the molecules reactivity, stability, donation, bond strength, bond length, everything can be judged from known clearly from the molecular orbital diagram of the respective molecules. So always remember that in case of heteronuclear molecule, there is a difference between sp mixing. One may occur sp mixing because of this hybridized orbital will maybe from this atomic orbital, they will be vanished. Again, due to the electronegative difference, one will have lower energy, will be placed lower, one will be upper, as a result of which the linear combination of atomic object will not take place in an usual manner with the identical atomic orbital, say 2s with 2s, 2p with 2p. So there is a difference. Due to this difference, there is non-bonding electrons. So sometimes non-bonding electrons towards the other one atom, sometimes it will be towards the other atom, and this non-bonding electron to which it is mainly belong to, this will depend on from what side the electron will get donated. So this all cases mainly can be known clearly from the molecular orbital diagram. So আজি মই যিকেইটা ডায়াগ্ৰাম দিলোঁ এইকেইটা যদি পুৰা ক্লিয়াৰলি জনা হয়, এইকেইটাই মষ্টলি ইউজ হৈ থাকে। নাইট্ৰজেন মনোক্সাইড ইজ এ very used ligand in case of organometallics, in case of anything. Carbon monoxide, carbonyl, this is carbonyl, metal carbonyls are very well known complexes. Again, HF, this is a very good, this is a very good acid, it's a strong acid. So these are very usually asked questions from molecular orbital theory topic. So please go through this and practice the others also. So some others are also there, BF3, H2, this polyatomic molecules are also there, but these are some tough, these are not usually asked. But if you have knowledge clearly about all these three, then you can answer anything and you can know about anything and attempt questions from this, every question from this topic. So clearly go through this one by one about the molecular orbital diagrams of heteronuclear molecule. If you have any doubt regarding any point, regarding anything, and if you have seen any kind of mistake here, so there may be something, so please discuss with me, please tell me in the comment section also. And if you have any question related to this, or if you want to know more of this topic, or if you want to suggest me for other topics also, please tell me personally or in the comment section, so that I may continue again with that topic which you all want to, or which many of you want to know about. So for today, this is it. So until next time, thank you and goodbye. Have a nice day.